Okay, so this is number 69 from A16. This problem reads that a 1,150 kilogram car pulls a 450 kilogram trailer. So I'm going to make that mass of the car, mass of the trailer. That's 450. So picture-wise, we have a car with some sort of trailer behind it. The car exerts a horizontal force of 3.8 times 10 to the 3 newtons against the ground in order to accelerate. So there's a third law case here. Essentially, the car pushes back this way. We'd call that force of car on ground. And the reaction to that force is what moves the car and subsequently the trailer forward. That's going to be F ground on car. And F ground on car is equal to 3.8 times 10 to the third newtons. We want to know what force does the car exert on the trailer. So what force, our questions are force on trailer, and we know that the coefficient of friction on the trailer, I'll sneak that in right here, is 0.15. So this problem essentially is asking us about the motion of the trailer, but we need to look at the motion of the car initially. The motion of the car, so let's do the motion of the whole system. Looks like the following, the force diagram. I have force of ground on car, and I have the force of friction on the trailer. Notice I'm ignoring the rope between the car and the trailer because I'm looking at the entire system. So the forces of tension on the car and on the rope are internal. They don't come from an outside force, an outside object. Therefore, they don't fit into the diagram. I also have normal and weight. What this diagram is going to tell us is the acceleration of the system. So I know the net force is equal to the force of G on C minus force of trailer, friction, that is. Notice I'm putting the negative sign in now. So I've already done the negatives, I don't need to do it later. This is going to be equal to mass times acceleration. So force of G on C. And force of friction can be calculated by mu times N. But that's going to be N for the trailer. So at this point, what I'm trying to do is solve for acceleration, but I need to keep in mind that this mass is the mass of the entire system, so car plus trailer. But over here, where I'm looking at normal force, it's the normal force of the trailer. So that's going to be m of the trailer times gravitational acceleration. So this equation will become A equals force of G on C minus mu m trailer times G divided by the mass of the system. Now, when I calculate this acceleration, let's take a minute and do that. When I substitute in numbers, I'm going to have 3 times 10 to the third newtons minus 0.15. Let me move this out of the way. 0.15. Mass of the trailer is 450 kilograms. And notice here I'm putting in positive 9.8 because remember, we put in the negative sign back up when we wrote out the net force equation. And this is all going to be divided by the total mass of the system, which is 1,150 kilograms, 1,150 kilograms plus 450 kilograms. That smart board is malfunctioning. When I do this out, I'm going to plug in the numbers. And I find an acceleration of 1.96 meters per second squared. So the point for doing this is we know that this is going to be the acceleration of the system. So for both the car and the trailer. So when I try to find the force on the trailer, I know the acceleration it has, 1.96 meters per second squared, and I happen to know the mass of the trailer is 450 kilograms. So the force required to accelerate can be determined from those numbers. Now the question reads, what force does the car exert on the trailer? So I need to go back a step and actually draw a force diagram for the car itself. No, sorry, for the trailer itself. I'm actually going to go back and give us a little more room. I'm going to add a page here. Go back. And so carrying over, I have the trailer, and the trailer has a rope attached to it that takes it to this car. I'm now going to draw a force diagram for the trailer specifically. So for the trailer, I have normal force, weight. Now I'm going to include tension because I'm only looking at the trailer. And the force of tension comes from an object outside the trailer. It comes from the car. And of course we have friction. So when I look at the system, when I look at this force diagram, I can write that the net force is equal to tension minus friction. And what we are trying to solve for is tension. That's the force of the car on the trailer. And that's what I'm trying to solve for. The left-hand side of this equation, net force is just equal to ma. And we know A from the work on the previous screen. A was equal to 1.96 meters per second squared. So at this point, I'm ready to solve for my final answer. Tension is going to equal mass times acceleration plus friction. Again, remember, I put the negative sign in the first line, so I don't have to worry about adding any negative signs when I put in 9.8. Mass times acceleration. Friction is mu times n, which is going to be simply mu times mg. A quick word here, n is equal to mg because we're on flat ground. And, I just lost one. And the acceleration in the y direction is 0. So the balance, normal force has to balance out with weight. So n equals mg. So now I can go ahead, that was ugly, I can go ahead and solve. I'm sorry, I keep having smartboard issues. So that is 450 kilograms, the mass of the trailer, times 1.96, the acceleration we found from the first part of the problem, plus the coefficient in this problem was 0.15. Again, mass is 450. And here I'm just going to put in 9.8. And I don't need to worry about a negative sign because the very first line of the problem up at the top of the page includes the direction. Now I'm ready to calculate. And I got a net force, or sorry, a tension equal to 1544 newtons. Okay, I'm going to pause and save.